Okay, so the method that we are using today is solving by square roots. So the way I do this one is I want to get all of my numbers to one side of the equation, and I want to keep the variable on the other. Yesterday we were graphing. So yesterday we wanted everything on the same side of the equation. Today I want the variables and the numbers on the opposite sides. So, guys, here I go. So my first step on number 1 is I'm going to add 31 to both sides. What is 49 plus 30?
80.
Okay.
You divide by 4. And then you square root.
Okay. What's the square root of 20? So when I take square roots, I want to do the factor tree. What are my factors of 20? Okay. What are my factors of 10? Okay, so do I have any pairs? 2. What I do when I take square roots is pairs go on the outside, losers stay on the inside. Losers. Think about it. If you don't have any friends, you're going to stay inside because you don't have anything to do. Jose!
What? I stay inside.
Okay, so my answer, because I took the square root, it's going to be plus and minus because it can be both positive and negative. And then I said the 2's can go outside because they have friends. And the 5 is a loser, so he stays inside the radical. Okay, so questions on number 1. Okay, so then what do I want to do for number 2?
You subtract 9 to both sides.
Okay.
And then divide by 3.
What's the square root of negative 3?
Positive 3.
Nothing. You can't take the square root of a negative number. So my answer here is no solution. It's not that bad. What? Yeah, so what I did was I started off by adding 31 to both sides because I want to get the x squared alone. Then I divided by 4. I took the square root because that's the opposite of squaring. And for 20, to take the square root, I had to do the factor tree. So I listed out all my factors. When I have a pair of factors, those can go outside the radical, and I only write it once. And when I have leftover numbers, those stay inside the radical. And then the reason it's plus and minus, because if this had been a number like 16, you could have negative 4 times negative 4 that would make a positive, and then positive 4 and positive 4 that would make a positive 16. Does that make sense? I broke up 10 into 2 and 5. Yeah, I only look at the bottom numbers of my factor tree. Like the ends of the branches. Okay. Number 3. The way you get rid of a fraction is you flip it. So I'm going to multiply by 5 halves. On the left side, it cancels out, and I'm just left with x plus 3 squared. What's 5 times 5 halves? 25 halves. because this 5 is over a secret 1, and remember when you multiply fractions, you multiply straight across. So 5 times 5 gives me 25, and 1 times 2 gave me the 2. Bless you. So then what I want to do is I want to do what next?
You subtract 3.
No, because it's inside the parentheses with the squared.
Distribute the square root.
I'm not going to distribute the squared. I'm going to do the square root. Okay? So on this equation, on the left side of the equation, the square root and the squared cancel out. So I have x plus 3 on the left, and then it's going to be plus and minus on the right. I can take the square root of 25. I don't know why I did my factor tree. Square root of 25 is 5. When I take the square root, though, of the top, I have to leave the square root on the bottom, because I can't take the square root of 2. What numbers multiply to 2, Diego? Multiply. 1 times 2, those are 2 different numbers. It needs to be 2 of the same. Okay? And then to solve, I just need to get x completely alone. So I subtract 3 on both sides. I have x equals negative 3 plus or minus 5 over the square root of 2. Questions there? Yeah?
How long is 12 raised?
A week.